Hey guys, and welcome back. Today we're going to be talking about the engineering fundamentals with an introduction to mechanical engineering concerning energy, motion, and mechanics. So, energy is the ability to do work. All mechanical tools need an energy source to do work. An automobile engine needs a fuel source to operate the many different components of a car, just like a bicycle needs a human energy source to pedal up a hill. The two types of energy are potential and kinetic. Potential energy is energy that is stored and waiting to be used. The energy that is found in a stretched rubber band is an example of mechanical potential energy. This stored energy is waiting to be used. Kinetic energy is energy in motion. Once the rubber band is released, the potential energy is converted to kinetic energy. Examples of kinetic energy include gears turning in an engine, fluid moving through a hydraulic pump, or the use of gravity in roller coasters. While potential energy alone does not produce work, when combined with technological tools, work can be accomplished. For example, springs are often used in mechanical systems because of their ability to convert potential energy to kinetic energy. Energy in motion that uses mechanical devices for conversion is called mechanical energy. Mechanical devices can be levers, wheels, gears, pistons, or more complex tools such as internal combustion engines. Mechanical engineers are concerned with conversion of energy using mechanical means. The conversion of mechanical energy often takes place in power systems. Power systems take energy and convert it into power to accomplish work. Many times, this conversion process uses multiple power systems to convert the energy into useful work. Power systems can be electrical, fluid, or mechanical. Mechanical power systems use one of 6 different types of motion, which we will talk about in a moment. But it is important to remember that objects in motion will move indefinitely unless slowed by friction. So what is motion? Motion is when a body is continuously changing its position with respect to the surroundings. Then we can say that that body is in motion. Some examples of motion are when an athlete is running on the ground. He is continuously changing his position with respect to the audience who are sitting at rest. We are continuously changing our position from morning till night with respect to the earth, which is considered at rest. And the earth is continuously changing its position with respect to the sun, which is also considered at rest. There are 6 different types of motion: linear motion, rotary motion, intermittent motion, reciprocating motion, oscillating motion, and irregular motion. So starting with linear motion. So linear motion is when a body moves either in a straight line or along a curved path, then we can say that it is executing linear motion. For example, an athlete running a 100-meter race along a straight track is said to be in linear motion. So a body is said to be in rotary motion when it stays in one place and turns round and round about an axis. For example, a rotating fan, a spinning top, or the earth are all examples of rotary motion. Intermittent motion starts and stops regularly. For example, in a cinema projector, the film needs to be moved on one frame at a time, then held stationary while the light projects it onto the screen. This is usually done with a Geneva stop, shown here. In this example, you can see how as the gear A rotates around, it will stop by using gear B. Every time that it hits a certain point, it's going to stop at an intermittent or regular interval. Reciprocating motion is a repetitive up and down or back and forth linear motion. It's found in a wide range of mechanisms, including reciprocating engines and pumps, as we see here to our right. Oscillatory motion. A body is said to be in oscillatory motion when it swings back and forth from a set position. So some examples would be the pendulum of a clock or even a simple swing. And finally, irregular motion, which is motion which has no obvious pattern to its movement. It's often needed in automation to recreate the movement of living things. As you can see here, rock, paper, scissors is an example of irregular motion. Moving on to simple machines. The fundamental concept of most designs developed by mechanical engineers rely on 6 simple machines. Simple machines are tools that make work life easier. They include the lever, the inclined plane, wheel and axle, screw, wedge, and pulley. Mechanical engineers use simple machines to provide a mechanical advantage. Mechanical advantage is the number of times a machine or tool multiplies the input force to move a load. This is why simple machines make it easier to do work. They can transform the input force by increasing the distance that what you're trying to move will move. So there's 3 different classes of levers, and levers are an essential part of many mechanisms. They can be used to change the amount, the strength, and the direction of movement. The position of the force and the load are interchangeable, and by moving them to different points on the lever, different effects can be produced. So the first class lever are like a seesaw or a balance. The load and the force are separated by the fulcrum. As one moves up, the other moves down. The amount of and strength of the movement is proportional to the distance from the fulcrum. Other examples would be a pair of scissors or even a claw hammer. The second class lever, an example like a wheelbarrow. Here, the load is between the force and the fulcrum. This uses mechanical advantage to ease lifting of a large weight. Other examples of a class 2 lever would be a car door or a pair of pliers. And finally, the third class lever. Here, the force is between the fulcrum and the load. Mechanical advantage is reduced, but the movement at the load point is increased. Examples would be curling weights with your bicep, a pair of tweezers, or even using a push broom. Another fundamental area of study for mechanical engineers is the area of mechanics. Mechanics is the study of forces and motion on physical objects. There are several important areas of study within mechanics, including statics and dynamics. In statics, engineers study how loads are applied to stationary objects. There are 2 main types of loads, forces and moments. Forces are loads that move on an object in a linear direction, push or pull, and moments are rotational loads or twisting forces. Engineers use statics to analyze the pushing, pulling, and twisting forces that are applied to objects. Dynamics are used to study the motion of objects, also known as kinematics, and the effects of forces on motion of objects, known as kinetics. Newton's laws of motion, acceleration, velocity, momentum, and vectors are all important concepts in the study of dynamics. And now we're moving on to tools. And so the tool that we're going to be talking about today is the micrometer. So selecting the correct gears, pulleys, shafts, and linkages require careful measurements. Mechanical engineers use accurate tools that can measure mechanical components. These tools provide precise measurements and are designed for specific uses. Engineers use micrometers to measure the outside size of different objects. There are 2 different types, the common or standard micrometer and the electronic version. When reading a common or standard metric micrometer, there's 4 different steps. Step 1 is to read the barrel. And so in this example right here, the barrel reading would be 5 millimeters. Step 2 is to read the half marks. In this specific example, there are no half marks, so it's going to be 0. Step number 3 would be read the thimble. And so in this example, you can see where the thimble reading is. And the thimble reading is 0.14 millimeters. And then step number 4 is to add all of those measurements together. So in this example here, you can see that the final reading is 5.14 millimeters. It's important to understand how to use both the common metric micrometer as well as the digital micrometer. Today, we learned about how mechanical engineers use the types of energy and motion in the planning of mechanical power systems, as well as how mechanical engineers depend on the types of simple machines and levers to give mechanical advantage when planning designs. We were also introduced to the fundamental areas of the study of mechanics, statics, and dynamics for mechanical engineers, as well as how to use a micrometer. In the next lesson, we will learn about mechanical and fluid power systems, as well as several mechanical power principles and formulas, such as how to calculate for pressure, torque, and gear ratios. I hope you guys enjoyed this lesson. Please get with your teacher if you have any questions, and I want you guys to have a great day.